So we're continuing in this third video with the decomposition of a vector into two constituent perpendicular vectors that when added together give the original vector. So in other words, I have a vector here shown in green. It's got a magnitude of 5, so I'm representing that length of the vector with a number 5, and it's going at an angle of 30 degrees to the x-axis. This may be, for example, the force of a child pulling a wagon, and that's what you're representing here. Maybe he's pulling the wagon with a force of 5 newtons or whatever, but at an angle of 30 degrees to the x-axis. So we want to know, can we take this vector and decompose it into two perpendicular vectors? And the answer is we certainly can do that. And again, all we have to do is a little bit of math, not anything scary or hard or difficult. We simply drop down and make a right triangle, and then we know that this length over here is going to be 5 times the cosine of that angle, and this length up here is going to be 5 times the sine of, let's say, 30 degrees is the angle we used. Now, if anybody has trouble with this, I simply refer you to the simple fact that if you have a right triangle and this is your angle here, and this is your y and this is x, then of course the cosine of this angle is the adjacent x over, in this case, let's just say this was our 5 vector. That's the magnitude here, over 5. If we multiply both sides by 5, we get 5 cos theta is x, which is this portion here, which is why we called it that. And with a little bit of algebra and trigonometry, you can easily see that this length over here is the sine function, 5, or the magnitude of the vector times the sine of the angle. So this green or yellow, depending on how your eye is seeing the color, can be decomposed into an x vector and a y vector. When added together, you get the resultant of 5. So let's draw this. How can I do it? Here. We started out with the yellow, and now I'm going to keep it in yellow for now. We have let's do it this way. It's easier for me anyway. We have a vector here, which we are calling magnitude 5 cosine 30. And we have another vector up here, which we are calling 5 sine of 30. These two perpendicular vectors, when added together, will produce this green vector going at an angle of 30 degrees. All right, and we went through that in video number 2, where we had the guy walking at 3 feet per second, wind was blowing. What was the result of it? Well, he kind of moved off the line a little bit because the wind pushed him, but he really was stronger than the wind, so he kind of went up at some kind of an angle like that. All right, but these two add up to give this vector. So we can show it vectorially, as we can say the vector whose magnitude is 5, I'm just putting that there like that so you can understand it, is equal to 5 times the cosine of 30 degrees. That is a vector in the x direction, plus 5 times the sine of 30 degrees, whatever that magnitude is. That's a vector in the y direction. So this vector component in the x direction plus this vector component in the y direction is going to give you the resultant vector. Now there's a reason I showed it this way, and that is because I want to talk to you a little bit about unit vectors. A unit vector is a very, very special and very important concept to understand. It's a vector that lies on an axis, and it has a magnitude of 1. So we call 1 unity, and that's why it's called the unit vector. It has a magnitude of 1 unit. So I'd like to introduce that now to you, because it's going to be very important, and it's not really that hard to understand. So let's assume that we have some x-axis and some y-axis. This is our x direction, this is our y direction. Then a unit vector, oh, let's show the unit vector in light blue. That's a good one for it. A unit vector would have a magnitude of 1, and it would be in this direction. And a unit vector in the y direction, for y we'll use a different color. Let's use this one, green. Has a length of 1 in the y direction. Now it has a length of 1, so that's its magnitude, and it's showing direction right along the x-axis. Now we give a special name to vector, a unit vector on the x-axis, and we tend to call this vector the I. Let me do that, sorry. Let's do it in same colors we're working with. This is the I vector, and instead of putting the little arrow on top to show it's a vector, since it's a very special kind of vector and its magnitude is simply 1, we just put a little hat on top of it like that, and that hat indicates this is a vector that's a unit vector, and it's in the x direction. How do we know it's x? Because we're calling it the letter I. The green one is a unit vector in the y direction, and we give that vector a special letter, and we call it j. And we put a little hat on top of it to show that it's a vector. Okay? So what would be the resultant? So the question is, what is the resultant of the unit vector I plus the unit vector j? What would be the resultant? Can we figure that out? Well, let's see. The resultant vector, I'll show that with a little arrow because that's our result, of vector I hat plus vector j hat equals what? Well, this is a magnitude 1. This has a magnitude of 1, and this has a magnitude of 1, and that's just the direction shown. So let's see if we could figure it out. If you've got 1 and 1, we've got something that goes off like this at an angle of 45 degrees because it's a square at that point. I could connect the arrowheads here. And we know this is going to be the square root of 2 because we have 1, 1, root 2. That's the 45, 45, 90 triangle. If we were to draw that, this is 1, 1. This will be 1 times the square root of 2, and that's a 45-degree angle. That's what happens when you have two same length parts. So the magnitude of this is going to have the magnitude of the root 2, and it's going to be, this is my symbol for angle. The angle here, theta, is going to be 45 degrees. So the result of a unit vector in the x plus a unit vector of the y is going to be root 2 times, root 2 at an angle of 45. In other words, you're going to have a vector whose magnitude is the root 2 at an angle of 45 degrees to the x or y axis. Okay? want to continue going on with this in the next video, so we'll stop it here and we'll continue unit vectors in the next video.